So this is an example of why you need logs, because we don't have any way to like, oh, divide by 5 on both sides. There's no like thing you can do to solve this. And so what you need to learn is how to make a log. The official name is logarithm. Would you please write the word log, L-O-G, and nobody's ever going to make you spell logarithm. So just write log. Be with me now. This is really important. You're learning something that you're going to have to use a whole new system of math called logs all the way into next year, and it's going to be on your AP pre-calc test for sure. I get to teach you first. All right, so this log is going to have a base, which is a little subscript number of 5, and that is called the base. So why don't you just label it? We're not going to take too many notes. Write this down. This is called the base. And the next number you would put comes from the circle of logs. I need to get you used to this. To do logs, you don't just read it in order from left to right. You don't. You bop around in a circle. So the next thing we pick up is the 24, and that 24 goes right there. And that's got a name, and it's called the argument. Log base 5 of 24, and then remember me calling it the circle of logs? It's because it comes around and hits that, and that's what brings it full circle. And then what do I write? I write equals x. See how it's now solved for x? X is alone, and x is equal to log base 5 of 24. Now, if I wanted to, I could just ask something smart like a calculator and say, what's log base 5 of 24? Let me try that. What's log base 5 of 24? Do you want me to use ChatGPT to answer that? Sure. Let's see if ChatGPT can figure it out. That's usually smart enough to do that. 1.975. Would you agree that would round to 1.98? All right. How did it get that? It looked it up. Seriously, this is just something you look up to get your final answers. And the calculator can look it up. There's some of them you can do in your head. Like, for example, if I said log base 3 of 9, I'd expect you to be able to do that one in your head. And I bet somebody can do it right now, and you know the answer already. What do you think it is? 2. Now, how the heck did they do that so fast? What they probably did is said 3 to the something equals 9. And they went, oh, 3 to the something equals 9, and that something must be 2. See what I'm saying? All right. Now, the next thing I want to teach you is how to pronounce this correctly. Because would you agree if Grandpa sees this written on the box, he's like trying to install his new bird feeder that uses Wi-Fi, and he reads this to you, he goes, I'm having trouble with the Wi-Fi. You'd be like, what? Oh, you mean Wi-Fi. And that means Grandpa doesn't know what the heck he's talking about, right? Well, if you said this as log 39, I know you don't know what the heck you're talking about because that's not how you say it. So let me teach you how to say it right. The way you say it is log base 3 of 9. And honestly, I wish it was called log base 3 argument 9 because that would make more sense to me because 9 is the argument. But this is how you're supposed to say it. Log base 3 of 9. That's worthy of writing down, and I know most of you are. Because then, later, when I ask you, like, read me problem 2, you'll know how to say it. Log base 3 of 9. And why was it equal to 2 again? Because of the circle of logs. The 3 goes to the x, and it equals 9. So I started with this kind of a problem, and I said, can you make a log for it? Log base 3 of 9 equals x. But what if I had started with this problem and said, can you make an equation for it that looks like it's got an exponent? I guess it's kind of like Jeopardy, where this is the answer, and now I want to know what the question was. Do you get you still could do the circle of logs? 3 to the x equals 9. This one's called log form. This one's called exponential form because it's got an x in the exponent. The way I'll usually say it, though, is I'll usually say write it with an exponent, because in this unit, the exponent won't always be x. Last unit, exponentials, the exponent was pretty much always x. But now, we might actually have the x over here, or the x might even be here, but it'll have an exponent when it's in this form, and it'll have a log when it's in this form. All right, so let's practice that. That's the biggest thing. If I got you through nothing else today, I'd want to be able to say, my kids can write logs. That's not a log, but you can write a log for it. And we shouldn't, what did you get?
Log base 9.
Log. Always, if you're ever stuck, just write the word log and you'll be forced to address that. I know there's some number next. Oh yeah, it's the base. And which of these looks like a base? The 9 does. Good start. And then you do the circle of logs. So, of 12, and you even said it right. Good job. And then what's next? Equals x. You need to finish it. So it's got an equation. So, and to be an equation, it has to have an equal sign and stuff on both sides. All right, cool. That's called log form. What if I gave you a log form? Log base 3 of x equals 11. To like understand what this problem really is, it would probably help to rewrite it. This is a log right now, and you probably really don't understand what it means. Rewrite this, please. The dice of destiny say row 2 and person 6, and that is Paige. Tell me, what did you rewrite it as? You did not do the circle of logs. I'd like you to try it again. And start with a 3 and think about the circle of logs. Uh-huh. That's what you wanted. So that's why a lot of times I'll say write it with an exponent. Because the tendency is people want to just put the x in the exponent. In this case, the x is not in the exponent spot. Get what I'm saying? All right. So if I needed to get the answer, I could use a calculator and go 3 to the power of 11, and that would be the answer. That's what x is. Some really big number. All right. How about another one with just variables? Log base b, which makes sense because, you know, that's the base. If you use logic, what letter am I going to write next? A, very good. A for argument. And this one will only make sense after you rewrite it. I'm going to choose an E here. Would you please rewrite this one using the circle of logs? But they're all numbers. What do I do? You start with a base, which is B, and you do the circle of logs. B to the E equals A. And why did I use a B in the base spot? Because B is the base. Why did I use an A in the argument spot? Because A is the argument. And this is the weird part. E does not look like it's an exponent when it's up here. But do you get it is actually going to be the exponent? So, when it's in log form, your exponent sits over here. But when it gets put into a form that has an exponent, then the exponent ends up here. That's called the exponent spot. Just as much as this is called the base spot, and this is called the argument spot, that's called the exponent spot. And again, it kind of breaks your, like, Like, what? That's not an exponent. It's just a number. It's sitting there by itself. It's not in an exponent position. But as soon as you rewrite it, it will be in the exponent position. Okay, good. Now, pre-calc loves to do this. Now do it without any numbers. What if I said m to the x is equal to q? Rewrite it as a log. Some of you probably could have handled being in pre-calc right now. It was actually possible, but you would have had to skip over this class, which would be very hard to do in reality. But there are some kids who are taking AP pre-calc as a 9th grader or even as an 8th grader. They have a few kids taking AP pre-calc as an 8th grader. All right. At least honors pre-calc, I'm not actually positive. I got to look this up, whether or not an 8th grader can test on the AP test or not. I don't know if they allow it. But at least you could take honors pre-calc as an 8th grader if you wanted to. So, log, and it'll force you to think, what am I going to write next? I need a base. Which one of those looks like a base? Oh, the m does. And then you can start your circle of logs. There you go. Can you go back and forth between logs and equations that have an exponent? You feel okay about those? All right. Then I got to get better at calculating them with you. So let's calculate some. I know the answer to this just because I know the pattern. Say the answer if you know it. 1 is correct. Nice call. Now think about why. Two to the 1 equals 2, doesn't it? Now I'll show you a way that you can recognize these the fastest, in my opinion. If you go like this, log base 3 of 3 squared equals x, I think that's the best way to show this to you. If these two are the same, then the answer will be whatever exponent this has. Let me explain why. And I'm going to give you my snappy little saying for this. If the bases are the same, the answer's already there. This is a base because it's called the base position of the log. This is a base because it has an exponent on it. So in its own way, that 3 with the 2 on it, that's kind of a base too. And the bases are the same. Then why is the answer 2? I bet I can show you the circle of logs. 3 to the x equals 3 to the second. And you can't look at that and not know that x must be 2. Jaden. Yeah, up here. All right, so what you're looking for is if the bases are the same, then the answer will be right there. Log base 5 of 5 to the 27th is equal to x, and the answer is what? 27. If you want to see why, it's because 5 to the x equals 5 to the 27. And then, of course, x has to be 27. It's the only way it would work. Okay. But then you have to get a little bit better at it. And some of you are going to get this right away, and some of you aren't. I know the answer. Raise your hand when you know the answer. Don't blurt it out, but raise your hand when you know the answer. 7, 8 people, 9, 10, 11, 12, 13. Tentative 14. All right, watch. 3 to the what is 9? 3 to the 2 is 9. And the answer is 2. But Did anybody do it this way in their head? That was a smart way to do it. Do you get that 9 is 3 squared? And then the bases are the same, so the answer's right there. All right, see if you get this one. Log base 3 of 1/3. Ooh, this test, do you remember fraction exponent thing? What'd you get? -1. Nice job, Josh. If you're still not seeing it, I could do it this way. Could I replace this 3, or 1/3, with a 3 to the -1? And then would you see that the answer is -1? All right. Say it as soon as you know it. 2. If you had to explain it to your little brother, you could replace this with a 4 squared and then be like, remember how I said if these are the same, the answer's already there? Okay. All right. Next one. This is going to mess with some heads, and some people are going to get it, and some people aren't, and that's okay. What's the answer? 8 to the power of log base 8 of 1. I think I heard an answer of 0 that's not right. Say it louder if you think you have it.
0.
0 is not correct.
Just 1.
Is it just 1? Nice. It's 1. Now let me explain why. Would you agree we didn't know the answer up front, so I could say equals x? When you don't know what it is, you could say equals x, and you're going to do this a lot. When you don't have a variable in it, you can just say equals the variable. Then, this is the weird part. This is in exponent form. I know it's got the word log in it, but it doesn't start with log. There's just a log in it. So if I want to rewrite this, do you remember the rewrite deal? Do you remember the circle of logs? 8 to the x. Nope, I'm doing it wrong. I am so sorry. Hold on. Hold that thought a second. I'm wrong. Here's what I said that was right. This is not in log form. And so here I was trying to write it in exponent form. It's already in an exponent form. What I got to do is write it as a log. Sorry about that. It's got to start with a log to be considered in log form. The other one just has a log in it. Now that I said that, and this is equal to x, now, maybe, is the time to use the circle of logs. What's the base going to be? Tell me your theory. 8 is correct. Log base 8 of x equals log base 8 of 1. Wait a minute. Everything's the same on both sides. Log base 8, so do you get why? If x was 1, it would have to be true. Do you get if I put a 1 there, doesn't it? That has to be 1. So you can look at this, and if you're good enough at it, you can say, oh, the answer is 1. And it'll follow what I said earlier. I said I was going to give you a snappy saying. I said if the bases are the same, the answer's already there. Are the bases the same? Yeah, and look at that. The answer was already there. It works in more than one situation. If the bases are the same, the answer's already there. I'll give you back to this kind. If I said log base 3 of 3 to the x, what's the answer? X. Because the base is the same. The answer is right there. The answer is x. If I wrote equals x, I could do that and then watch what happens. 3 to the x equals 3 to the x. Look at that. It worked. All right. So if the bases are the same, the answer is already there. All right. 10 to the log base 10 of 14. What's the answer? 14. Bases are the same. The answer's already there. It's 14. And if I get these are tricky. You could say equals x, and then you could go, Mr. Server said it's actually not a log unless it starts with log. So log, what would the base be? It seems like it should be a 10. And then you do the circle of logs thing. And once you got all that written out, you'll be able to use logic and go, oh, x has to be 14. Okay. We're pretty much there. What that means is we're ready to start the homework. So everybody, find the homework for today. And I'm going to tell you which ones we're going to do and which ones we're going to skip. We're going to skip all the CDs, JK. Look at the worksheet. Which ones did you think I told you to skip just now? Everything that has a C and a D. And what did I say at the end? A J and a K. Any part of the problem that has a C or a D or a J or a K are all skips. Please cross them off right now before you forget. Cross off any C and any D and any J and any K. And then let's start it together. And Weishan, would you read me number 1A?
It says log base 21 of 25.
Ooh, he even said it right. Log base 21 of 25. Did you say 21, 25 or?
Log base 2.1.
Oh, 2.1. Sorry about that. Log base 2.1 of what?
25.
And then what do they want?
They want the base and the argument.
Ooh, that's an easy one. What's the base? 2.1. What's the argument? 25. That's easy. Okay, how about B?
Log base 9 square root of 8.
All right. Now remember that 8 could be written as a 2 to the third, but that wouldn't really help us because that doesn't match this base here, right? Like if I could make those bases match, I would, but 2 to the third doesn't really help. But be thinking that way. Because like if I could make this into a 9, it'd be really slick. But all I probably want is the base and the argument, so then it's super easy. The base is 9, the argument square root of 8. Okay. And we're skipping the C and the D, right? And we should number 2.
2a is, it says rewrite each expression in exponential form. It's log base 3 of 9 equals n.
And then what's the exponential form? Well, I actually don't like it because exponentials are supposed to have an x in the exponent. This will have an n in the exponent. And it isn't even always there. Sometimes the variable is in the base spot. Sometimes the variable is over where the 9 is. The variable isn't always where the n is. It is this time. And if they asked me to solve it, I'd be able to do it. Would you? If they asked me to solve it, I'd know what the answer is. It'd just be 2. They didn't ask me to solve it, so I don't have to. Talon, what's number 3? A.
5 to the power n equals 25.
And what do they want?
Rewrite each expression in logarithmic.
Ooh, so it's log. Can you do it? What's the base?
5
Yup, circle of logs.
of 25
Keep going.
equals n.
Yes. And again, if they wanted the answer, I'd know it was 2. Because that 25 could be 5 squared. And all right. I think you get the idea. And I think if you need some extra help, you know where I'll be. So I want to help you. You just have to ask. And that's all I got for you for today. You learned the basics of logs. Now, later this hour, you're going to get tests back. I want to remind everybody that's getting a test back today that if you want to have the cumulative give you a better score, I have a rule. And that is that you have to correct the mistakes that you made on the first test. Now, I give an exception for this. If you got a 95, then I'll let you out of doing corrections because you did pretty dang well. You don't really have too many mistakes. Okay, so 95s, don't have to do corrections. But anything lower than a 95, you have to fix your mistakes. You got to admit, if you fix your mistakes, much more likely to do better on the cumulative then. So it's going to only help you do better. But if you got anything lower than a 95, think about doing those corrections. I have a sheet you do it on. That's all I got for you for today.